And welcome viewers. In the previous segment, we have covered the center-tapped full-wave rectifier. We already know that full-wave rectifiers can be classified into two types, such as center-tapped full-wave rectifier and bridge rectifier. In today's lecture, we will discuss the bridge rectifier and why this was taken as an alternative to center-tapped full-wave rectifier. But before we delve right into it, let's wonder how the welding power supply works. Welding power supplies consist of welding transformer. The welding transformer's internal architecture is shown. We can see that a bridge rectifier is used to convert alternating current AC to the desired direct current, which is DC. Definition: a bridge rectifier is a type of full-wave rectifier which uses 4 or more diodes in a bridge circuit configuration to efficiently convert the alternating current, which is AC, into direct current DC. We have discussed earlier that construction of a center-tapped full-wave rectifier is difficult as well as costly. The bridge rectifier overcomes this major limitation of a center-tapped full-wave rectifier. It uses 4 diodes D1, D2, D3 and D4 along with a transformer and a load resistance RL. The 4 diodes are connected across the load. During positive half cycle, we can see from the diagram that during positive half cycle, terminal A is positive whereas terminal B is negative. This means that diodes D1 and D3 are in forward bias whereas diodes D2 and D4 are reversed bias. Now, when the voltage is more than the threshold voltage, diodes D1 and D3 will conduct the current across the load whereas diodes D2 and D4 will not conduct any current. The voltage developed across RL will be positive at terminal D and negative at terminal C. Case 2. During negative half cycle. Similarly, we can see from the diagram that during negative half cycle, terminal B is positive whereas terminal A is negative. Diodes D2 and D4 are in forward bias whereas diodes D1 and D3 are reversed bias. Now, when the voltage is more than the threshold voltage, diodes D2 and D4 will conduct the current across the load whereas diodes D1 and D3 will not conduct any current. The voltage developed across RL will be positive at terminal D and negative at terminal C. We notice that voltage across load resistance RL is always positive at terminal D and always negative at terminal C. This is because the current flows in the same direction, that is from terminal D to terminal C in both the cases. Since the direction of current is unidirectional in nature for both cases, hence this is how a bridge rectifier converts an alternating current AC to direct current DC. Filter circuit. As we have discussed in the previous segment, pulsated DC output is of no use to practical applications. Just like we use a filter circuit for center-tapped full-wave rectifier, similarly we will use a filter circuit for bridge rectifier to obtain a fine DC output. A filter circuit for a bridge rectifier is shown here. Here we can see that a capacitor is attached across the load resistance RL. Case 1. Positive half cycle. During positive half cycle, we see that the capacitor charges through diodes D1 and D3. Now just when the negative pulse arrives, the charging of the capacitor begins to stop and the charge is discharged through RL. Negative half cycle. During negative half cycle, we see that the capacitor charges through diodes D2 and D4. Now just when the positive pulse arrives, the charging of the capacitor begins to stop and the charge is discharged through RL. This can be shown with the waveform. This is how we obtain a fine DC output which is not pulsating in nature. Now let's discuss the advantages and disadvantages of a bridge rectifier. Advantages. The need of center-tapped full-wave rectifier is eliminated. The transformer utilization factor is higher. The PIV of half to that of a center-tapped full-wave rectifier thus making it suitable for high voltage application. Disadvantages. It requires 4 diodes. The circuit is to rectify small signals. In today's lecture, we have learned types of rectifiers, introduction and theory of a bridge rectifier, filter circuit of a bridge rectifier, advantages and disadvantages of a bridge rectifier. With this, we are at the end of this lecture. We will meet again in the next lecture with another topic. Till then, learn and practice properly. Thank you and goodbye.